Now, where does variation comes from? So we've talked about variation, that it has to do with passing of what traits from the parent to their offspring so that they can better survive in their environment. So where does variation comes from? Actually, it comes from genetic mutation. So we talk about sexual reproduction, because before you can have variation, there must be offsprings, and these offsprings come up as a result of the intercourse between the partners, male and female, and this is going to lead to the transmission of certain genetic compositions, right? So half of these compositions come from the mother, the male, and half of it come from the female parents. So both male and female parents will contribute traits, genetic traits, that will make the offspring to better survive in its community or in its environment. So when it gets these traits from the parents, then the traits can either be positive or negative. Are you listening?
Mm-hmm.
So if the offspring is getting good traits from both parents, then it's going to be an advantage for this offspring. So it's going to cause what we call a genetic mutation of advantage for that offspring. And that kind of an offspring will better survive in the environment. But if the traits transmitted to the offspring are actually traits that are not of good quality, then the offspring is going to be of disadvantage, and then most likely the offspring might not survive within that community or that environment. So variation comes actually from transmission of traits as a result of reproduction from both parents, mother, sorry, male and female parents, to improve the quality of the offspring. So it can be positive and it could be negative. So when it is positive, there is survival. When it is negative, there is extinction. Is that clear?
Mm-hmm.
Now, mutation are random. So we said mutation come up as a result of transmission of these traits. The better quality mutations survive, while the ones that are not okay dies off. So this is just the summary here. They said mutation are random. If a mutation is beneficial, organisms will likely survive. Pass on mutation, that is called selective advantage. So we call that the selective advantage. Okay, selective advantage comes in when we have better quality of trait transmitted from our parent to the offsprings. So this is going to make the offspring organisms to survive better in the environment. That is called selective advantage. Okay. So, but if the mutation is harmful, the organism might not survive. So the organism is likely to die, and these traits might not be passed on forever. So this becomes a selective disadvantage. Is that clear? So
Yes.
yeah, we have example: a mutation in the red blood cell gene causes sickle cell anemia. Carriers of this gene who do not exhibit the disease have an increased resistance to malaria. We have the survival of the fetus. Now, what do we mean by survival of the fetus? Just like we said, um, we have a number of organisms in an environment. Some will have good physical traits. They have good quality and genes. They've obtained the better quality and genes from their offspring, I mean from their parents, and they have that better opportunity to survive within their environment. So as a result, they can live longer, they can run away from predators, they can feed better, and um, they can live better in a nutshell. But you are going to have some of these organisms that might have, they might not be able to fit much within the system. So this kind of organism will die easily in the environment. So that what we call survival of the fittest comes in. It is only those who are fit within that community or within that environment among the organism that will survive. Those that are not fit will die, while those that are fit will survive within the community or within the environment, and they continue to survive and bring up offspring of a better quality. Now, this brings about what we call the natural selection. This brings about what? The natural selection.